So today we're going to cover Chapter 2, Section 6. It's the last section we need to cover before Tuesday's test. So today we're going to be combining functions. We'll be adding, subtracting, multiplying, dividing. And then we're also going to be doing composition of functions. So when we combine functions, they're going to give you two different function names, and there'll be some type of operation symbol in between. So we'll either have a plus sign in between, a subtraction. If the two function names are side by side, that means multiply. And then if it's written as a fraction, that means we're going to be dividing the fractions. And again, remember, when we divide, we never want the denominator to be a 0. So that's what this exclusion is over here, that the g of x function cannot be a 0. So let's go ahead and go through some examples. And we're going to combine. And I know the yellow is kind of hard to see, but we're going to be adding the two functions for number 1 and adding for number 2, and then subtracting for number 3 and for number 4. Now, when they want us to have just the x there, all we're really doing here is combining like terms. Then when there's a 2 after the operation that they're expecting you to do, or the combination, then you're going to actually plug that number in for x. So once I combine them in number 1, I can use that result to answer number 2. So when it's got a plus sign, all I'm really doing here is adding like terms. So I'm going to write down the f of x function, then I'm going to add the g of x function, and all I'm doing is combining like terms. So I don't have any x squared terms to combine, so I'm just going to write down x squared. I'm going to go back. I've got a 2x and a 2x. I can add those, and that gives me 4x. And then the ones, positive 1 minus 1 is 0, so that would be my combined function. It'll be x squared plus 4x. Now, I want to do the same thing. They wanted me to combine f and g, which I already did, but now they want me to plug in 2 for x. So I'm just going to take my combined function here. So f plus g, and then of x, so that simplified function was the x squared plus 4x. Now I'm going to plug in a 2 every place that I see an x. Follow order of operations. So 2 squared plus 4 times 2 gives me 4 plus 8. So then my final answer of f plus g of 2 is equal to 12. I'm going to subtract the two functions now. And what you have to do is be very careful, and we're going to need to distribute the subtraction sign. So I'm doing, essentially what I'm doing here is the f of x function minus the g of x function. So f of x is 2x plus 1 minus, and when I go to write down the g of x function, I'm going to put a parenthesis here because I need to remember that I'm subtracting every term. Now you could either think of this subtraction sign as a -1 that you're going to distribute. Let me see if I can do it in red so it shows up. Or just do like a keep flip change. So I'm distributing a subtraction sign to everything in here. So it's really going to be 2x plus 1 minus x squared minus 2x. And then negative times negative is a positive 1 at the end. Now I'm going to go back and look for like terms. So I've got nothing to add with the x squared. I'm going to get my x's. 2x minus 2x. X's are gone. And then now I'm going to go and combine my constants. And I'm going to do 1 plus 1, and I get 2. So that would be the combined functions when I'm subtracting them. And now to answer number 4, again, I'm going to use the combined function. So again, f minus g of 2, if I first just show that f minus g means take the f of x function, subtract the g of x, I'm going to take that combined function, which was negative x squared plus 2. I'm now going to place a 2 every place that I see an x. I'm going to square the 2, drop down the negative sign, and negative 4 plus 2 gives me negative 2. So f minus g of 2 is equal to negative 2. Yes?
What makes it like, how do you know if it's gonna, if the negative sign is gonna drop down or if it's gonna stay with the...
So anytime your variable is like this, where it's a negative x squared, whatever number you're plugging in here for x, I would put it in as a parentheses. So like, let's say you were plugging in a negative 2, this would still turn into a positive 4, and then you drop down the negative sign. Or again, you could think of this as a negative 1 times the x squared, and the x is the only thing that has the exponent, not that negative sign. Does that make sense? Let's try another combination. This time we're going to multiply and divide. Actually, sorry, only multiply. So the next slide, again, they'll either see a closed little dot indicating multiplication, or they would just write the 2 function letters side by side. So again, I'm going to go ahead and combine them first in terms of x, and then I'm going to take that combined answer and use it to answer number 6. So let me go ahead and multiply them. Again, I am going to have to distribute here. So this dot means really f of x times g of x, and my f of x function is x squared, and then I'm going to multiply that to the g of x. So I'm going to distribute x squared times x is x cubed, x squared times negative 3 is negative 3x squared. And that's my final answer there in terms of x. Now I'm going to take this combined function, and f of g of x is what we just got, x cubed minus 3x squared. And now what I'm going to do is f of g, and I'm going to plug in a 4. So 4 cubed, 3 times 4 squared. 4 to the 3rd power is 64. 4 squared is 16. 64 minus 3 times 16 is 48. 64 minus 48 is 16. So f multiplied to g, plugging in a 4, and the answer is 16. Okay, so this time they're not asking me to plug in numbers. They're actually just asking me to simplify it, to divide them, and then they're asking me to give the domain. So when I go ahead, and this really means f of x divided by g of x. So I'm going to do the square root of x. Let me do a different color here. The square root of x over 4 minus x squared. So that would be the combined function. That's all I do. Now, to find the domain, remember, we automatically always start out by thinking the domain is going to be all real numbers, except when we have a fraction and when we have a square root. So for this one, I need to look for restrictions. So for my numerator, the domain of the f of x function, which is just the square root of x. So remember what we do when we check for the domain when it's a radical, we're going to set it to be, we don't want any negatives. So our check would be greater than or equal to 0. So the domain for the f of x function is from 0 to infinity. Now I have to do the domain for the g of x function, which is the denominator. Which is 4 minus x squared. So again, when it's in the denominator and it's a radical, we're just setting it greater than 0 because we can't have it equal 0. So I could just go ahead and add the x squared here. 4 is, and again, I'm going to treat it as if it's an equal sign. And then square root it, plus and minus 2. Now this is where we have to do, it's a quadratic, so we had to do the x check thing. So again, I can plug in a 0. 0's here in the middle. So when I plug in a 0 into 4 minus x squared greater than 0, 4 greater than 0, this is true. So I get a check there, and I would get x's here. So the domain for the denominator is going to be from -2 to +2. Now remember, when we have a check for both, we have to find the overlap. So if I put this on my number line, the domain for the f of x function, let me add these numbers here, -2, 0, and 2. So for the numerator, what it is, it's a closed circle on 0, and all numbers greater. And then for the denominator, it was the open circle, and the segment in between. And now I need to find out where I see both blue and red, which is right here. So the domain of the combined function is from 0 to 2 with a parentheses. So this would be the domain of the f of g of x. So you're going to find the domain of the f of x function, of the g of x function, and then you're going to find where the overlap is. So when we go to combine it, so for number 8, it wants g of x divided by f of x. So the g of x function is just the 4 minus x squared under the radical over the square root of x. That's my combined function. Nothing to do. I just put it in its places. But now I need to find the domain of it. And again, it's going to be the same. I can go ahead and test it out though. So for the numerator, 4 minus x squared, I know it has to be greater than or equal to 0. So I can add the x squared. 4 equals x squared, square root it, plus minus 2. Again, you do your x check thing. We already did it, but we know that 0 worked. So check right there. So the domain now of the numerator is actually brackets with -2, 2. And then the denominator, x has to be greater than 0. So here we would do 0 with a parentheses to infinity. So then now the combined -2, 0, 2. So greater than 0 would be this. And then the other one would be closed circles here and here. So now the domain for this is going to be a parenthesis around 0. And then it's going to stop right here at the 2 with a bracket. So the domain for g over f of x, it's the same numbers, but the grouping symbol moves. All right, next we are going to talk about composite functions. And notice the little circle there. It's an open circle. It's not a dot. So this is read as like f composed with g. For the first one, or we would say G is composed with F. So what we're going to be doing is our input now is going to be one of the functions. So here we're going to take the G of X function and we're going to plug it into the F of X function every place that we would see an X. And then vice versa. Take the F of X function and plug it in to the G of X. So really, this is our input that we're plugging in to the first letter. And this is what we're inputting. So let's go ahead and try some examples of these. So again, it's not a multiplication symbol, it's an open circle. So really what this means is we're taking and plugging in the g of x function into the f of x function. So really what we're saying here is plug in 4 minus x squared for x in the f of x function. So if I write down my f of x function, x plus 2, and where I see x, I'm going to put this in its place. So really what I'm writing here is 4 minus x squared instead of the x, and then put the plus 2. And then I look for like terms. I can add the 4 and the 2, and I just end up with 6 minus x squared. And I'm done. Now let's reverse it. And now what we're going to do is we're really saying take the g of x function and plug in the f of x for all the places where we see x. So again, what we're really saying is plug in x plus 2 every place that we're going to see an x in the g of x function. So my g of x function, if it helps you to write it down, and again, what we're replacing here is x plus 2 where I see the x. So I'm going to be writing 4 minus, and then in its place I'm going to put x plus 2, and then it still has the square. I got to FOIL that x plus 2. Remember, you can't just put the exponent on the x and the 2. You got to write it twice and FOIL it. Either that or memorize the pattern. So this just becomes 4 minus, and then in the parentheses, I'm going to put x squared plus 4x plus 4. That's the answer I got when I did x plus 2 times x plus 2, which is really what means x plus 2 squared. Now I need to distribute that subtraction sign, and this becomes 4 minus x squared minus 4x minus 4. I'm now going to go back and look for like terms. The only like terms I have are the 4 minus 4, and those are gone. So my final composite function is negative x squared minus 4x. Now to answer number 11, notice it still has the same, the composition of g of f, and I'm going to plug in a negative 2. So I'm going to take this answer I just got, put it over here, and I'm going to plug in a negative 2. So negative x squared minus 4x. Every place that I see x, I'm going to plug in a negative 2. And again, be careful with your negative signs. So what I'm going to do is put the negative sign. When I replace x, I'm going to put it in parentheses, just so I can see it a little clearer. And now I need to follow order of operations here. So I'm going to do the exponent here first. Negative 2 squared is positive 4. The negative sign comes down in front. And then I can actually multiply these guys. Negative 4 times negative 2 gives me positive 8. And now I can add negative 4 plus 8, and my answer is positive 4. Okay, let's try examples 12, 13, and 14. Again, this really means I'm taking the f of x function and plugging in g of x. So really what I'm doing here is instead of x, I'm plugging in the g of x, which is 4x plus 1, 4x squared plus 1. So again, if it helps you to write down the f of x function, 2x plus 5, and again, we're taking out x, and in its place, I'm putting in 4x squared plus 1. So 2, and then 4x squared plus 1, and then the plus 5. I need to distribute the 2. I get 8x squared plus 2 plus 5. I've got like terms that I can combine here. I can combine the 2 and the 5. And my final answer is 8x squared plus 7. Now let me go right below it. I'm going to do number 14 because notice it's the same function. It just wants me now to plug in negative 1/2 for my x value. And then I'll go do 13 because then that one's reversed. So I'm going to take what I just solved, the 8x squared plus 7, and where I see x, I'm going to replace it with negative 1/2. And then just follow order of operations. So I'm going to do 8 times negative 1/2 squared. I got to follow PEMDAS. I got to do the exponent first before I multiply. So negative 1/2 squared is 1/4. And now I can multiply that by 8, and I get 2. And then I add the 7, and final answer is 9. Now I'm going to do it in reverse, and I'm going to do the composition of the g of f. So let's go ahead and do that. So again, this is really saying take the f of x function and plug it into the g of x function for x. So again, it's really saying g of 2x plus 5. So again, if you write down your g of x function, which is 4x squared plus 1, again, we're taking out only the x and replacing it with the f of x function. So again, let me rewrite this. 4 2x plus 5 squared plus 1. Again, I got to FOIL that thing. I can't distribute the 4 first. We have to follow order of operations. So exponents come before multiplication. So when I FOIL that thing, writing it twice and FOILing it, I get 4x squared plus 20x plus 25. And then I drop down the plus 1. Now I distribute the 4. And I get 16x squared plus 80x plus 100 plus 1. The only thing I need to combine is the 100 plus 1. And my final answer, 16x squared plus 80x plus 101. Next, we're going to find the domain of a composite function. So if you're finding the composition of the f of g of x function there, so f composed with g, you're going to bring down the domain of the g of x, and then you're going to look for any additional restrictions from the result of your composition. So we're going to find the domain of the final answer, but then we also have to find the domain of what we inputted, the g of x. And then we'll do a combination of those. So let's go ahead, and you're really looking for example, on this one. So if I had, write it the other way, g of f of x, I'm going to find the domain of the result of combining this, but then I also have to look at the domain, any restrictions on your input of your f of x function. So we're going to look at the domain of that. So let's go ahead and try it. So first thing I need to do is combine these two functions. So here, it's telling me to really say f and take the g of x function and plug it in. So we're really saying f, and then we're using as an input 9 minus x squared under the radical. So if I write down my f of x function, it's x squared minus 9. So again, what I'm replacing is the x, taking this out, and I'm going to put this in its place. So I'm really saying 9 minus x squared under the radical, but then it still had it squared. And remember, when you square a radical, it makes it disappear. So this just comes out, and it's 9 minus x squared minus 9. The 9's cancel, and my composition is negative x squared. Now remember, all domains start out as all real numbers. So here, there's no restrictions. I don't have a fraction and I don't have a radical. I don't have a square root. So the domain of my combined function is all real numbers. However, I need to go back and check out the domain of what I inputted, the g of x function. So the domain for the g of x function is going to be what's under the radical greater than or equal to 0. So add x squared, and again, treat this as an equal sign. So 9 is greater or equal to x squared, square root it, plus and minus 3. Again, remember when you solve a quadratic inequality, we need to do that x check thing. So what we're going to do here is put -3 and +3. And if I plug in 0 into 9 minus x squared greater than or equal to 0, 9 minus 0, 9 is greater than or equal to 0. So in the middle, I get the check mark and then the x. So the domain of the g of x function is actually going to be from -3 to +3. So then now what we need to do is the domain of the combined function is going to be a combination of the all real numbers and of the g of x function. So since there were no restrictions on the combined, the domain for my combined function is going to be the restrictions from my input. So the domain of f, the composition of f and g, so the domain of this is going to be the inputted domain. So from -3 to +3. Now when you're doing the WebAssign tonight, it's actually going to ask you to find the domain of the f of x, the g of x, and then of the combined function. So it's going to ask you to find the domain of all three. So the domain of my f of x function is all real numbers. The domain of the g of x is my final answer here, which is also the domain of the composite function. So what you have to take into consideration is the function you plugged in. You also have to consider that. So if I were to graph this on a number line, the domain of the composite function is the whole number line. It's everything because it's all real numbers. But the domain of the g of x function, remember, is this. So we would put -3, +3. So it would be this. And again, it's where you see both. That's the composite. Yes?
Where did the x go in the first, like when you plugged in f?
Where did the x go?
Where you have it like
At the beginning?
yeah.
So this was the function I'm plugging it into, x squared minus 9. And what I did was I took out x and I replaced it with this. Does that make sense? And then the radical disappears because we squared it. Does that answer your question?
Yeah.
Okay. All right, let's try one more. So again, we have to combine them first. So really what we're doing here is taking, again, the g of x function and plugging it into the f of x. So we're really doing taking x squared plus 4, and we're plugging it in to the f of x function. So the f of x function is just the square root of x. So I'm just going to take this out, and I'm going to replace it with x squared plus 4. So my combined function is just the square root of x squared plus 4. That is the combined function. Now I have to check the domain. So remember, we always assume the function is all real numbers, except when we have a radical and when we have a square root. So here, the domain of this one is going to be x squared plus 4 is going to be greater than or equal to 0 because it's not in the denominator. We just want positive values. When I go to solve this as if it's an equal sign, I get x squared equals negative 4. And when I go to solve this, I would be getting plus and minus 2i. I don't care about excluding imaginaries, so the domain of this is all real numbers of the composite function. I don't care, this answer that I'm asking you to exclude is imaginary, and I'm only looking to exclude reals. So the domain of the combined function is all real numbers. Now I have to also go back and look at the domain of my g of x function, because that was my input. My g of x function is just x squared plus 4. So here, again, no fraction, no radical, so the domain for this is also all real numbers. So because both the combined function and the input function has all real numbers, my final answer here, the domain of the composite function is going to be all real numbers. And again, in the web assign tonight, they're going to ask you to give the domain of the f of x, the domain of the g of x, and then the domain of the combined. Technically, we don't care about the f of x function when we're doing the composite because that wasn't what our input was. But if it was this, if it was set up like, then we would worry about the f of x function. It's always the inputted function that you worried about for their restrictions. So that is it. Again, there's a review posted. And start looking at it and get your questions ready for Monday. Any homework questions? Okay.